Hello, future mathematician. Let's do example 3. So now we want to determine the inverse of f of x, which is equals to 1 over x, 1 over 2x squared, where the domain is restricted. Is restricted such that x is greater than or equals to 0. So now, how do we determine the inverse? Remember, the f of x is the same as y equals to 1 over 2x squared. First, you interchange x and y. X is equals to 1 over 2 to the power y squared. You cross multiply, you have y squared, end up having 2x. Take the square root both sides. Y is equals to plus or minus the square root of what? 2x. So since the values of x are restricted, we're only taking the positive values of f of x. The only thing, if the x is positive, the y must be also positive. Meaningly, we don't take the negative, we must go positive, positive. Therefore, we can conclude the inverse of f of x is equals to the square root of 2x in that manner. So let's draw the function, the original and the inverse, and you will see what I'm talking about. So here we have x, here we have y. So normally the function supposed to goes like this because it's a happy function, but we have an issue. They have said the x is a restriction. X is greater than or equal to 0. So 0 is here and x greater than 0 is this side. It means we don't have this part. Then you have to erase this part. So the graph does not exist here. So the graph of parabola only exists on this one. So how do we draw the inverse? It's simple. Let's check. Here it was positive and here it was positive. It means the inverse must go positive, positive also. It must go positive, positive, positive. When we interchange positive and positive, there is no change. So, but remember, by the look of things, since it was positive, the first one, it's supposed to goes like this. This is not fair enough. So the graph supposed to go like this, but this negative part, we remove it since we have said x must be greater than 0. So here is our new function and its inverse. This is f of x, this is the f inverse. So we can draw the line y equals to x. It must pass through the point there. Let me redraw it. Big, yeah. So it will go like this. So this is my function, and then the line y equals to x, this one. This is not fair enough. I think this is perfect. Then we can use a dotted line. So it must be a straight line like this one. Then this is the line y equals to x. So this one is the inverse. This is the f of x. So this is how you supposed to draw it. So the domain, let's do the domain. The domain of f, domain of f, domain of f, it cannot be x the element of all real numbers. Is that restriction? X is greater than or equals to 0, and the range of f The range of f you can see is y must be greater than or equal to 0 also. Then what about the domain and the range of the inverse? So the domain of the f inverse, you are going to read the range here, which is y greater than 0. It's the same as x must be greater than or equal to 0, and the range of the inverse. So you're going to read the domain, replacing it with y. This one, y must be also greater than or equals to 0. Thank you for watching. We will meet on the next video.